alternating current. Is it here? So simply this, if we will take here a conductor, is it? There is a conductor. We will apply the potential difference. What potential difference? Direct potential difference. Is it? Here it is a switch. Positive, negative. Then when the potential difference is applied, the current starts flowing. Right now, the drift of current takes place here. But if I will replace here the source means here I will take an alternating source. The symbol for alternating source is this here. Got it? This is alternating source. It's called AC voltage. The formula for the voltage is V naught sine omega t. And the interesting thing, where this is coming from here. This voltage source, what is the voltage source here? And therefore means this alternating voltage is the variable voltage. Means it will not work in constant way. It will vary according to a mathematical function. That mathematical function is called sine function. That's why with time or sine function of time means with time it will vary. That's called time function, sine function of time. The voltage is sine function of time. If you will draw the graph for this typical graph, right now, if you will draw the graph between voltage and time, then what type of graph will come here? This, the graphical pattern will here this. Is it or not? And hence this is called sinusoidal. What is called that here? Sinusoidal. It's called sinusoidal voltage or called sine voltage. Simply it's called sine voltage or it's called alternating voltage. Why alternating being called here this? Is it here? Is it? This is due to that here alternating. After each half interval it's changing direction, or after each negative the positive will come here. The next positive comes just after one half signal. Is called alternating. Is it here? So this alternating voltage, when we will apply cross conductor, then what will happen? Current will start flowing. In what manner the current will start flowing? The current will start flowing. First the current will flow in this. Is it here? The second will current flow in this. It means for half signal, the current will flow in one direction, and in the next half the current will flow in back direction. So we can speak here during one complete cycle. The current will flow from, suppose that is point A or this is point B. So first the current will flow from A to B, and second the current will flow from B to A again. Is it here? So we can say vector wise the displacement will become zero. No, nothing else will happen in it. We will find an average value because electric energy is not a vector quantity. Energy is a scalar quantity. Then will it make effect zero? No sir. This will make effect a positive effect that we'll talk about here. Is it here? So we are starting here the alternating voltage. So this device we are replacing by, there are three fundamental devices, passive devices that we will discuss in the chapter. These three fundamental devices are called, first we will discuss about the resistance, second we will discuss about capacitor, and third fundamental device passive is called that inductor. It's called resistor, this is called capacitor, and this is called inductor. Across these three devices, if we will apply the potential difference, alternating potential difference, then how current will start to flow. Is it here? Like, so first we are taking here that, look, that is, here is alternating voltage applied across resistor. It's V naught sine omega t. Here again, V naught sine omega t. Got it? Here also, we have connected these all. Like this. When an alternating voltage is applied across, here you will write, fill in the blanks. Here you will write resistor, right now, resistor. In case of resistor you will write R, in case of capacitor you will write capacitor, C, in case of that you will write an inductor. Is it here? And while studying the current dependency over voltage, you must know their characteristics, property of resistor, how resistor works, how capacitor works, and how inductor works. Is it here? Across an inductor, then instant current at any instant the current through here again fill in the blanks. In case of resistor you will write R, in case of that you will write C capacitor, in case of that you will write an inductor. Is it here? That is, so look that here. Alternating voltage is this here. Is this forming a complete loop here? Yes, obviously it's forming a complete loop here. Is it? So by Kirchhoff law we can at any instant we can move across the loop or anti-loop. Is it here? Across voltage. Look, at any instant the current is given as I. But since V is equal to what is that here? I into R. V is equal to I into R at any instant. So what the voltage is here? Here voltage will be V naught sine omega t is equal to IR. Here it is by Ohm's law. Ohm's law. Conclusion. The current flow through the resistor by Ohm's law. Is it here? And the current flow through the capacitor by capacitance concept here. What the concept here? That is C is equal to Q by V. Here the flow of charge according to this relation right now. And here inductance what here? Minus of L. Do you remember this here? Di by what? Minus of L Di by dt. Is it? This is that here. Got it? The current at an instant is given by that. Got it? Now next is V sine omega t. So in place of that, therefore I is equal to. So I is equal to V naught sine omega t, and here we'll divide it by R. Is it? So since it is the what species here we brought, it is a current. So obviously the right hand side will also be current. So this is a function. So this will be what? Please tell me. This will be maximum current. Is it or not? It's this here. This is the equation of current, means function of current. So when alternating voltage is applied across a resistor, at the same time current starts, or current flow through sine function. Current flow via sine function. With a, right now the current can be represented by the sine function. It means how happens between current and resistor, current and voltage? Simply it is when you apply the potential difference, alternating voltage. Is it? At the same time current flow here. That at the same time we are representing this as a current. Here it is this here. The blue one is the voltage, and the red one is the current. As the current increases, you will see that here. As voltage increases, at the same time voltage increases. Is it here? When the voltage go maximum, the current will go maximum. Have you studied the maximum or minimum? Is it here? Same as it is. As the voltage go minimum, the current go minimum. Is it here? Means when one happens, the other happens same. It goes maximum, it go minimum. So two quantity are at the same time achieving maximum value. Then this is called what? In same phase. Means there this quantity is same actually. Is it here? And the quantity aside the function is called phase. So we'll speak here, these are in the same phase. Like that two players start running. Let ready start, 1, 2, 3, run. So they have to start in the same place. If there is some difference between them, it's called the phase difference. Is it here? So do you understand what is the meaning? So here you will write when the voltage is applied across. You write here this. When the potential difference is applied across, when potential difference applied across, so here you will write when PD with alternating PD, when PD applied across a pure resistor, the current flows through that. Which current, please tell me? AC current. Current flow through that, through the resistor resistor in, what you will write here, in same phase. This is very interesting thing here. Same phase. What same phase means? Do you know what? This quantity is same in both the case. This is called in same phase. So equation of voltage, alternate equation of voltage is what here? V sin omega t, or current